So this is really weird, definitely. And in the notes, you'll see a page that talks about the magic tubes. And it shows a picture of not a full pipe, but more like a really, really short piece of pipe, a ring. Okay? As the magnet enters the ring, the magnetic field at this location is changing. And the flux through this little ring here is changing. And so Faraday's law and Lenz's law come into play, and they create their own magnetic field that will try to keep the total flux the same. The only way to do that is to oppose the magnetic field that's getting closer and therefore stronger. So by adding an opposite field, that makes the total a little bit weaker again, which makes the flux closer to what it was originally. So in order to do that, so our magnet's coming down here, right? Let's say that this is the direction of the field from the magnet. So coming down here, all right, now the pipe or ring needs to create a magnetic field pointing upward. The only way to do that is for there to be moving charges. So we have no batteries or anything, but we do have a conductor, and a conductor has charges that can move. So what happens is the charges in the walls are going to move to create this upward magnetic field. Now, we know that in general, a bar magnet is a lot like a current loop. So the current is going to go in a loop, one way or the other. And to figure out which way, we look at the direction of the field it creates. So it's creating an upward field, right-hand rule. That means the positive charges, or the current, must be going around this way. Okay? So that's as the magnet approaches. So what we've essentially got is an electromagnet with a field pointing up and an approaching bar magnet with a field pointing down. That's like having a north pole facing a north pole, so they repel. Then, remember, we're pretending this is very short, okay? So the magnet has entered the ring and now it's leaving. Okay, well, the magnet creates a field that's down, right? Still down, it's been down the entire time as it falls. That means that it's creating a flux through the bottom part here with a field that's pointing down and getting weaker because the magnet's getting further away. Now, Faraday's law and Lenz's law say, well, no, we don't want the flux to change. Right now, the flux is getting smaller because the field that's causing it is getting smaller. So in order to boost it back to original levels, we're going to have to add to that field in the same direction. So an induced current forms around the loop that will create an additional induced magnetic field to add to the one from the magnet. So this time, the current has to go in the other direction. So as the magnet comes in, the current goes one way. As the magnet goes out, the current goes the other way. But for both parts, the magnet is being slowed. Here, it was like having a north pole facing a north pole. At the bottom, well, we have a south pole on the top, right? And then here, we also have a north pole because the field is pointing out. So we have north, we have south, they attract. So at the top, the pipe pushes up on the magnet, making it fall slower. At the bottom, the pipe pulls on the magnet, making it fall slower. And this happens all the way through. You can think of a pipe as just a stack of metal rings. And each ring is seeing a magnet coming or going. And each ring is slowing the magnet down.